Okay, before we get started, let's just quickly remind ourselves on the basics of graphing the sine curve and the cosine curve. So remember, the sine curve starts at 0 and then goes up. So I'm going to put a little x at 0. Remember, the sine curve has a period of 360, so it's going to go up and then down and then come back and finish at 360. So when I graph the sine curve, I start at 0, I finish at 360. I know that halfway between 0 and 360, which is 180, it comes back to 0 because it goes up and then comes back through 0 halfway and then goes down and comes back. So I usually start by doing the beginning and the end. Then I go to the middle and get back to 0. Then I look at between the 0 and the middle. That's halfway between those is 90, and it goes to its highest point up at 1. And because I know it goes up to 1. And then halfway between the middle and the end is 270, and it goes down to its minimum point of -1. And then we'll draw this sketch of the sine curve. So let's see how well I do with my mouse. I know that it's not always easy. It's a little wobbly there, but I'm sure you'll give me a break. That's pretty good. Not bad. So there is our sine curve. Now the cosine curve, if you remember from last one, cosine curve starts at 1. So it starts up here at 1. And then it's going to go down and finish down and go down to -1 and then come back. And it finishes also at 360. Also has a period of 360, but it comes back to 1. Again, I start by doing the beginning and the end. And then I go halfway between those two is 180. But instead of going to 0, it goes down to its lowest point. So it goes up like this. Starts at 1, goes down, and then goes down to -1 halfway. And then comes back and then all the way back up to 1. So I start by doing the beginning, the end, then I do the middle down at the lowest point. Then I look at the beginning and the middle. Halfway between those for the cosine curve, it goes through 0. So it's going to go through 0 right there at 90. Then it comes down to -1, and then halfway between the middle and the end, it also goes through 0, and it goes, that's at 270, and then it finishes up at 1. So if I'm going to draw the cosine curve, I'll have it go like this. Again, forgive me for trying to do this with the mouse. Oh, I kind of missed a little bit there. Ugh. Okay, not bad. Maybe if I just sort of cheated a little bit over. That's a little better. Okay, remember at the beginning and the end, I have these little dips back down. I don't want us to think it's a parabola. I don't want to see the graph going up and continuing up like that because it doesn't go above 0, so we're not going to have that. It's just going to reach its max and then start dipping back down to its minimum. Okay, so these 5 critical points for the sine curve and the cosine curve are critical because we're going to be sketching all sorts of transformations on these basic curves.
And we want to do, in this case, 2 sine theta. So we're going to take our regular sine wave and we're going to do 2 sine theta. So that means we are vertically stretching it by a factor of 2. Okay? So basically we can calculate it by multiplying our y coordinates by 2. So here's the original. You went over 0, up 0. If I did this, I'm going to take my y coordinate and I'm going to times it by 2. Perfect. Okay. And then 90 and what? 2. So this would be 90 and 2. This one would be 180 and 0. Question? Oh, okay. Okay, what would this one be? -2, so it'd be 270.
Do you not times it by 2 to the first number?
No, just the y coordinates. Because we're just going to stretch it vertically. Yeah, so it's just our y values only. And this one would be 0. Yep. So 360, 0. So let's see how that's going to look as a graph. So I'm going to start at 0, 0. And then I'm going to go over to 90, up to 2. And then I'm going to go over to 180 up to 0. And I'm going to go over to 270 down to -2. And then I'm going to go over to 360 and up to 0. Now if we join that together. So that's what it's going to look like. We're vertically stretching it. So I'm taking those points and I'm stretching them and I'm timesing it by 2. I'm making it go twice as high. So are we okay with that? What would my amplitude of this one be? Remember your amplitude. Go from your equation of your axis, how much up
I
you go.
was like reading like the box down the sides too.
Oh, no, 2.
2, yes. So you went up 1, went up 2, yeah. So you're right. Don't read the boxes because in this case, this is a half, 1, 1.5, 2. Yep. So absolutely, this is our amplitude is 2 in this one. So this next one, we've got 1/2 sine of 0. So again, we're going to multiply our y coordinates in this case by 1/2. So 0, 0. Okay. And then 90, 1/2. Which one would you guys like? 0.5. And this one's going to be 180. Oops. It's the 180, 0. And then this one's going to be
270. Oh, you're right from that one.
always start from your original, your parent one. Negative 0.5. And then this one will be, yep. Okay, so I go over 0, 0, go over 90, up 1/2, go over 180, 0, go over 180, sorry, go over 270 down to negative 1/2, and then over 360 and 0. So what's my amplitude of that one? 1/2.
Just look at the, you can just look at the number that.
I just think half of it. Yeah, we're not going to be making this chart ever. We're going to look at our original sine wave and go, oh, I need 1/2 of that. 1/2 of 1 is 1/2. Double 1 is 2. So yes, we're just doing this to get the idea of what we're doing first. Yep. Okay, everybody okay with that?
Yes.
Okay, so when we have a number here, this is vertical stretch and compression. We are taking our y values and timesing them by whatever our a value is. This time, our equation's a little different. Now that 2 is in there, inside. It's not vertical anymore. Now we're going to do horizontal. So we are doing horizontal now when it's inside. So vertical is the one in front. Horizontal is the one inside. Okay, so this time because it's horizontal, we are going to take our x coordinates. Oops, I should have went over here. And we're going to divide our x coordinates by 2. So not our y, it's not a vertical, it's a horizontal. So we're going to deal with our x values. So for this one right here, 0, 0. Okay, now we're going to take our x coordinate and divide it by 2. So 90 divided by 2? 45. So 45 comma 1. Okay, let's take this one right here. 180 divided by 2. Okay, let's take this one right here. 270 divided by 2. 360 divided by 2. So we're taking our X values and dividing them by 2. So let's go put that on. So over 0, up 0. Then we're going over 45 and up 1. So it's only halfway over now. Then we're going to go over to 90 and up 0. Then we're going to go over to 135 and down to -1. And then we're going to go over to 180 and up to 0. That's like that. So you have horizontally compressed it by 2. Remember, it's the opposite inside the bracket. So how long did it take to go through one complete cycle? 180. So my period is 180. What was it on my normal one? 360. 360, yep. Okay, now let's do the same thing, but with a half. So again, we're taking our X values and timesing them by a half. So 0 times a half. 0, yep. 90 divided by a half. Okay. Yeah. Okay, so I'm just going to do it right here in that way. So I've got 90 and I'm dividing it by 1/2. Okay, so I'm just going to rewrite this as 90 divided by 1/2. Whenever you divide by a fraction, we flip it and multiply. So this is 90. We're going to flip this to 2 over 1 and multiply, which is why Will's saying 180. Okay, so 180 and then 1. 180 divided by a half. Yep. 270 divided by a half. 360 divided by a half. Okay, so let's put that one on. So over 0, up 0. And then I'm going over to 180 and up 1. Then I'm going over to 360, 0. And over to 540, down to -1, and over to 720, 0. So it's going to look like this. So how long does it take to get through one cycle? So the period of your function is this. 360 divided by k. So if it's 360 divided by 2, 180. If it's 360 divided by half, that's like timesing 2, it's 720. So your period is always 360 divided by whatever your k value is, and that's going to be how we start graphing it, because k is your number of cycles in 360 degrees. K is that number in here. That's your k value. So really, really important to remember that k is 360. Sorry, your period is 360 divided by k. And when I say your period is 360 divided by k, that is true for sine waves or cosine waves. It doesn't matter what it is.
So in this first example, we're asked to sketch y equals 3 sine theta. So first we'll notice that, of course, we should notice that we're graphing sine, so that's an important thing. But we notice that there is a number in front of that function. It's outside the function, so it affects the y values. The y values are going to get multiplied by 3. So that means that the amplitude of this one, amplitude, is going to equal 3. There's no other inside the function stuff. There's no left, right, up, or down. So this is just a graph that is has an amplitude of 3. That's what that part tells me. So now I've got to draw a graph on here with an amplitude of 3. So the first thing you're going to notice is the graphs I'm giving you don't have any scales. And I'm doing that on purpose because I want you to be able to anticipate what a good scale would be based on the graph that you're going to be doing. So if we had like our old scale, maybe where we went 1, 2, 3, 4 and called this 1, and I have to now go up to an amplitude of 3, this is a bad scale. So I don't want to do that. I got to pick something that's going to be big enough so that we can get all the way up to 3. So I could just do 1, 2, 3 like that, and that would be fine. But I think I have enough room to go sort of every 2. So there's 1, there's 2, and there's 3. Similarly down here to -1, -2, and -3. And then we have to pick x value as well. There's no period change on this, so I just got to make sure that it's big enough to be able to go through one cycle. I think if I went 45, did here and did 90, and then 2 over do 180. You have to forgive my writing with a mouse. This one would be 270. And then 2 more will make 360. And that will get me one cycle of the sine curve. All right, so what I would recommend is whenever you're going to do one of these, that you draw the original sine curve first. So let's just draw a sine curve in this scale, because it's good that we have a reference for the reader. Especially if we change the scale, we want to see what our original one would look like. So I'm going to draw a sine curve. Remember our 5 critical points. Sine curve starts at 0, ends at 360. Halfway between those is back at 0 again. So there's at 180. Halfway between the first and the middle, it's up to its maximum. In this case, if the original is just an amplitude of 3, I know mine's going to be 4 in a second, or sorry, an amplitude of 1. My amplitude is going to be 3 in a second. And then halfway between these two, I go down to my minimum. And then here's me going to try and draw a nice little sine curve with my mouse. Forgive me. All right, except for a little bobble at the end there. I'm pretty proud of myself for that. That's not bad. So just drawing a regular sine curve, make it a little reference. You can do that with lightly with a pencil, which is what I'm going to do. I'm just going to go here and make it a little light. Yeah, I'll just lighten it up a little bit. So it's just there as a reference point, maybe lightly in pencil. And now the graph that I have to draw is the whole thing, 3 sine theta. So all that changes in this graph is an amplitude of 3. So I'm going to start at x, or at 0, excuse me, finish at 360 because the period's going to be same. Halfway between these two is 180. And then halfway between the middle and the end, now instead of going to 1, my amplitude, my max is going up to 3. So it's going to go all the way there. And then between the middle and the end, halfway between those, it goes to the minimum, its lowest point, which normally is -1, but this one goes to -3. And so now I have all the basics for my 3 sine theta. So let's see how well I can sketch 3 sine theta. Hopefully you can do a pretty good job on your pencil. A little too pointy there and I wobbly up again, but that's not bad. I'm pretty happy with that. And so there's the graph of y equals 3 sine theta. Now let's check our answer in Desmos just to make sure it looks good. So I've got there's y equals sine x or sine theta here. You know that I noticed that I have more than one cycle because I thought we should visualize the entire cycle. But when we're sketching, we're only going to sketch from 0 to 180 or 360. And so then here's y equals 3 sine theta. And so we can see that it has the same period, but it obviously goes up to 3. So our graph is pretty good. All right, for example 2, we're going to now look and notice that we are graphing cosine. That's the most important thing we got to notice right away. It's cosine. So although we also have a different amplitude and period happening, we've got to be graphing cosine. So let's first look at what the number out front does. So of course that's going to change our amplitude. So this is going to have an amplitude of 4. And so we know that our graph is going to have to be pretty big. It's going to be going up pretty high. So we'll have to make sure we choose an appropriate scale for that. But then the second thing we notice here is that we've got a 2 inside. That's inside the function. So that's going to do a vertical stretch or compression, opposite to what we think. So we see that it's a 2. That means everything is going to be half as big. And what is affected when we stretch or compress vertically as opposed to horizontal? Vertically, that means we're changing our period. So the 2 means that our period is going to happen twice as fast. Now, if you remember, our formula is 360 divided by k. So don't worry about the half part. That's just reminding us that it's going to be half as big. The k value is 2. So that means we're going to go 360 divided by 2. That's where the period will be half as big. And 360 divided by 2, of course, is 180 degrees. So now our period is half as big as the original. It's 180 degrees. So we'll need to make sure we have that happening. Okay, so let's pick an appropriate scale. Now, if we pick the same scale as we did in the last one, 2, 4, like this was 1, 2, 3, we're going to be off the graph. So I think we better pick something a little bit smaller. 1, 2, 3, 4. And similarly in the negatives, -1, -2, -3, and -4. And I think if we pick the same scale as we did in the previous one, sort of do the same scale here, then I think that would work out because it'll just be shrunk a bit. Now let's see if I can maybe copy and paste these and use it in mine here. Oh, that looks like pretty good. Hey, look at that. So I'll give you a second to adjust your graph. Do the same scale, like 2 ticks, so 45, 90, another 2 ticks, 180, another 2 ticks, 270, another 2 ticks, 360. All right, so first thing we should do is, just like in the one before, let's start with our basic curve. And because this one is cosine, we have to draw the cosine curve. So we're just going to draw a cosine curve first. So if you remember, cosine starts at 1. So we're going to start at 1, then it's going to go down and come up and finish at 360. This is the original cosine curve, not the one that we're up here. Halfway between 0 and the end, it's at 180, and it goes down to the lowest point, which again is now -1. Then halfway between the middle and the beginning and the middle, it comes back to 0. And halfway between the middle and the end, it comes back to 0. And so we're going to get a cosine curve that's going to look something like this. And remember, don't have the cosine curve go off like that, because it doesn't go up like a parabola, it comes back down. And we have that. So another good advantage of getting this, not only do you have a reference, but it really shows what a regular cosine curve looks like in this scale. Of course, the ones we've done before, it's much bigger, but that was a different scale. This one's going to have an amplitude of 4, so we had to change the scale to make it a little bit smaller. I'm going to, again, do this in pencil, so I'm just going to do it lightly and have it just in the background there as reference. All right. Now, we can do this in 2 steps, and I think I will this first time do it in 2 steps. But I'm going to show you how I think we could maybe do it in 1. So let's just redraw it with an amplitude of 4. So I'll do like a purple curve for this for just the amplitude of 4. So for cosine curve, it doesn't start at 1 anymore, it starts at 4. So it's going to go there. We're going to assume the period's the same, so that means it's going to end at 4 at 360. Halfway between these two is the middle at 180, and now it's going to go down to -4. And then halfway between the middle and the beginning, it comes back to 0. And halfway between the middle and the end, it comes back to 0. And we have, this is 4 cos theta. It's a little too V-like. I'd rather have a little more curve and a little wobbly, but not bad. I'm okay with that. So there's 4 cos theta. But now this purple graph has to have a new period of 180. So we're still going to start here. Our new starting point is at 4. But now instead of going all the way to 360, it's going to end at 180. And then we get that. And then halfway between the middle and the end, it's at its lowest point, just like this purple one. So halfway between those is 90 now, and it goes down to its lowest point, which is -4. And then just like the purple, halfway between the beginning and the middle, it's back to 0. So now the beginning and the middle of this blue one is back to 0 here. And between the middle and the end, it's back to 0. And we have the new actual answer of 4 cosine 2 theta. Now, having the 2 steps is fine, but I'm going to suggest that maybe we could have done this all in 1 step. So I'm going to get rid of, I'm going to sort of backtrack here. Having the 2 steps on your graph is nothing bad at all. But I'm going to go back and show you what I think we could probably do in 1 step. So we're going to go right back to here. So still draw the green original as a reference, but I'm going to suggest we can go straight to this and do the amplitude and the period in 1 step. So the cosine curve is supposed to start at 1, but with the new amplitude, it's going to start at 4. Normally it would finish at 360, but let's make the adjustment of our new period at 180 right now. So we're still going to start at 4, but now we're going to end at 180 where it comes back to 4. And then just like we did before, now that we've effectively changed the period right there, now we just got to redraw this cosine curve with a new beginning and a new end. So halfway between the beginning and the end is the middle. In this case, it's at 90, and it would go down to its minimum. Because the amplitude is 4, it would go down to -4. And then halfway between the beginning and the middle, just like in this one, it's back to 0, but the new beginning and the new middle is right there. So halfway between that is 45. It's back to 0. And then on the cosine curve, halfway between the middle and the end, it's back to 0. So the new middle and the new end is here, back to 0. And then we can draw this. Yeah, not bad. It's a little too V-like there, but that's pretty good. So you can see how I think you could do the amplitude and period in 1 step, and you wouldn't have to draw that purple intermediate step. If you're more comfortable with that, that's fine. But I feel like we can probably do those in 1 step. All right, let's go to Desmos and see if we get this right. So I'm going to pull up my same graph as before, but now my original is cosine. So there's a cosine curve. A little bit deeper than that. If I scale back a bit, you can kind of see the little original cosine curve. And the one we're doing now is 4 sine 2 theta, or 2x. And so now you can see there's that blue graph. It's going all the way up to 4, but its period is 180. And in fact, if you really wanted to just see that one graph, we could go between 0 is less than or equal to x is less than or equal to 180, and it would just show that one cycle that we're having there. But I don't mind, as I'm on Desmos, to remind myself that it's just going to keep going on and on and on in both directions. So we can have that. But that one cycle that we just drew from here to here is exactly what we have on our graph. Okay, let's try another one. So in this one, you'll notice we're back to drawing sine. Okay, so let's make a little mental note that if you in fact want to write it out here, or let's just do this, I can type it out. So one of the steps is just to remind myself it's sine. All right, let's look at this part here. That is, of course, going to be the amplitude. And this time the amplitude equals 1/2. Okay, so the amplitude is going to be 1/2. Good. And then this number here is going to affect my period. Again, it's opposite to what we think. So the 1/4 is opposite. It's actually going to be a stretch. And I think it's going to be 4 times as big, opposite to what we think. Again, I don't have to worry too much about that if I remember my formula. So it's 360 divided by the K value, which in this case is 1/4. So since you are dividing by 1/4, that means you're going to multiply by the reciprocal. So 360 times the reciprocal is 4/1. And just as expected, this graph is now going to have a period that is 4 times bigger. So 360 times 4 is 1440. So this graph is going to be really long. The period is going to have to be really, really big. And we're going to have to make sure we choose a graph or a scale that will allow us to see this really long period. Okay, so a couple of things. Now I got to pick a scale. So for my y value, I notice the amplitude is going to be 1/2. So I don't want to really squish this into too far. So I think I'm going to make this 1 and this 2, just a pretty basic scale. And I'm going to make this -1 and -2. And I could have gone like 1, 2, 3, 4 and made 1 up here and really expand that scale so you have lots of room. But I think this is fine. And then now I get to pick something that's going to be 1440. That's going to be 4 times bigger than what I had scaled before here. So if I go 360 and I want to go 4 times bigger, that's going to be way off my graph. So I think though, if I go sort of 1, 2 and make that 360, so that'd be 180 and 360. So make every 2 another 360. So 360 plus 360, this is going to be 720. Forgive me for that, that's 720. Add another 360, that's 1080. And then 1, 2, 360 is going to get me to the 1440. All right. So now I've really compressed my scale in order to be able to see this really long period. Okay, again, I'm going to start by drawing my sine curve. So it's important to draw the sine curve within this scale so we have a reference. So we're just going to draw a regular sine curve that starts at 0, ends at 360. Of course, on this scale, 360 is right there. Halfway between those is 180. So it's right here. Halfway between the beginning and the middle is up at its highest point, which is 1. And a regular sine curve, not this one, but a regular sine curve would go down to -1. And then I'll draw this trying to make it not too pointy on my mouse. That's not bad. And I'm going to do it nice and lightly, so that just to my pencil, so that I can just use it as reference. All right. Next, I have to change the amplitude and the period. So I think I'm going to do both of these at one step. So period is going to be, let's do that in blue, excuse me. So period is 1440 and the amplitude is 1/2. So the sine curve is going to still start at 0, but instead of going to 360, it's now going to end all the way down here at 1440. So there is my beginning and my end. We know the sine curve comes back to 0 in the middle between those. So halfway between those and those is at 720. You can see there's the middle spot. And then halfway between the beginning and the middle, it goes up to its maximum. So between the beginning and the new middle, it's going to go up. So halfway between that is 360. It's going to go up to its maximum, but its maximum is only 1/2. So we're only going to go up this high. And then there's the sine curve between the middle and the end. It goes down to its minimum. So there's middle and end. Halfway between that is 1080. And it's going to go down to its minimum, which now, because the amplitude is 1/2, it's only going to go up there. So this is going to be a very long sine curve and not very high. So let's see if I can draw this. There we go. It's not bad. All right. Okay, and there is our final graph. Now we should on this somehow maybe sort of label these. So maybe you can draw an arrow to it, especially if you have more than one graph on here. So we could do that, and maybe we can just take this and copy it down here, make it blue. So I've just put some label on there so we know which one we're doing, that there's no mistake in the original graph with your answer. So there's that. Okay, let's go to Desmos and check this. So now my original is sine, not cos anymore. So they're back to sine. And I'm going to zoom in a little bit because I know the amplitude is going to be much smaller. So let's remind ourselves, what's this? This is 1/2 sine 1/4 x. Okay, so let's go back to Desmos. So this is 1/2 sine, I have to do it in brackets here. There we go. Still shows that same idea. There we go. There's the 1/2 times 1/4. So you still see it's definitely way longer, and it's only going up to 1/2. So I'm going to have to zoom out here in order to see the entire scale. And there it is at 440 coming back. So there's my sine curve starting here and only going up to 1/2. There's is at 1/2 at 360 and 1/2. Then it's coming back to 0. There it's down to -1/2 at 1080, and then back to 0. And that really matches this graph that we have there. So that's pretty good. All right. Just with these first few, these last two where I've had the period change, I want to reiterate this idea of what the 2 represents. So we know the 2, the first thing based on what we learned when we were sketching other functions is it's opposite to what we think. So we see the 2 there, you would think maybe it's stretched, but it's actually compressed by 1/2. So we see the period is all 1/2 as big, so it moves in there. But there are 2 other ways to think about it. The second is to just use the formula, 360 divided by 2 gets 180. The 1/2 is big, so the period used to be 360, so it's 1/2 as big, so that's 180. The third way is to imagine that this 2 also tells you how many cycles this will happen in the old period. So this blue graph now, it will take 2 cycles within the old period. Excuse me. So the old period is 360, and it will do 2 complete cycles before getting to 360. So that's another way you can imagine it. And then that means if it takes 2 complete cycles in the old period, then a single period must be 360 divided by 2, 180. So all 3 of those are great 3 ways to imagine what's going on. Think of this guy. So here the 1/4. So first we could just think of our formula. 360 divided by 1/4 is the same as multiplying by the reciprocal. We get 4. That's one way. Second is 1/4 is opposite to what you think. You see a quarter, you think that's shrunk. It's not. It's stretched by a factor of 4. So that's the 360 is 4 times bigger. That's the same idea. So it's 4 times bigger. So now we're at a 1440. And the third way is to say 1/4 says I am only being able to do 1/4 of a cycle in the old period. So if I look at the original green graph, you see how it finishes at 360. This is the quarter says I've only completed 1/4 of my cycle at 360. And we can see that happening here. Back here, it said we can do 2 cycles in 360. So I can repeat another cycle of this graph, and get 2 cycles all in before 360. So just another way to imagine what's going on here. If I go back to Desmos here, we can see at 360, I've only completed 1/4 of the graph. I've only made it to its max, and there's still all these other spots to do. If I was doing that cosine one, so let's put the cosine one back. And what was the graph of my cosine curve? The cosine curve was 4 cos 2 theta. Okay, so this is now 4 cos 2x. Zoom back in so we can see this. So there's my old cosine curve, and it finishes, one cycle finishes at 360. But now you can see that I have 1 cycle and then a second cycle all done before I get to 360. So that's why the 2 is there. So it means I could fit 2 cycles in there, which means 1 cycle must be half as big. All right, I'm going to give you a couple of minutes to try this one on your own. I'll notice a few things though, that we're graphing sine, that's important. We've got this k value of 2, so that's going to affect our period. We've already had a k value of 2, so that should be helpful. It has an amplitude of 3, and we've done one with an amplitude of 3. What's a little bit different is the negative. So that means that the entire thing is going to be flipped vertically. So instead of the graph going up like a sine curve like that, it's going to go down. Okay, so I'm going to give you a second to try this on your own. In fact, I'll give you exactly 2 minutes, and in the background, I'm going to set a timer. Now, knowing that some of you will probably be distracted by the timer on the screen, I'm going to put it back to your question. So there's 2 minutes there. Let's go back to the sketch. If you need some more time, then feel free to pause the video. But I think we're going to move on. So let's look at this. So first off, yes, let's remind ourselves we are graphing the sine curve. Okay, so let's put that in there first. And we know there's the amplitude is 3. But we also know that it's flipped vertically. Okay, remember the amplitude's not -3. The amplitude is a value, a distance. So it is, the amplitude is always going to be a positive value, but it is flipped vertically. So those are the two things we'll need there. All right, so that's coming from the -3, good. This 2 then tells me a couple of things. Remember, since it's inside the function, it's half as big, so the period is going to be half as big. So I already think I know that the formula is half of 360, so I think it's going to be 180. I can confirm that by using the formula 360 divided by k. In this case, since k is 2, it's 360 divided by 2, which is 180. And the third way I can think of it is in the old period of 360, I can fit 2 cycles in there, which means 1 cycle must be half as big. All right, we're going to pick a scale here that's going to be appropriate to fit all of this in. Our old scale of right back here, let's see if I can't use this scale again. Sort of going up by 45s. So if I go here, go 45, so 2 ticks 90, 2 ticks 180, 2 ticks 270, 2 ticks 360, I think is good. Amplitude is 3, so I think I can pick the old scale for that guy. I had one that was an amplitude of 3. That looks good right there. So I'll just copy these over here. So this one, I have every 2 ticks is 1. So there we go. So that'd be big enough to have a nice amplitude. All right, I'm going to graph sine curve by itself with just plain old sine, so I have a reference. Remember that sine starts at 0, ends at 360. Halfway between 0 and 180, or 360 is 180, it comes back to 0. Halfway between the beginning and the middle, it's at 90, and it goes up to its max, which a regular sine curve has a max of 1. Halfway between 0 and the middle and the end, it goes to its minimum, and the regular sine curve is 1, goes down to -1. And then we'll try our best to sketch the sine curve with a wobbly mouse. That's pretty good. And I'm going to do it lightly with my pencil. Oh. This will give you a chance to catch up if you haven't already. So there's a light sketch of the sine curve. Now let's go off and do the period and amplitude at the same time and also flip it vertically. So I think I can do all of these at once. So there is that. There is 180 and it's flipped vertically. So that means it's going to go down first. All right, let's try this. So it's still going to start at 0, except instead of finishing at 360, it's going to finish at 180. So there it is at 180. Halfway between those two, it's back to 0, so we get this. Now, halfway between the beginning at the end, normally it would go all the way up to 3 at its maximum. But because this is flipped vertically, it's going to go down to its minimum here, and it's going to go all the way down to -3. So it's going to come down to -3, back to 0. And then halfway between the middle and the end, it's supposed to be at its min, but because it's flipped vertically, it's going to go to its max. And instead of the max being 1, it's going to go all the way up to 3. And so putting those two together, and I can get this pretty skinny and tall sine curve. That's not bad. And then make sure, of course, you label it appropriately. Let's check our graph on Desmos. So there's a sine curve, regular sine curve at 360. This is -3 sine 2x. And so it goes down to -3, passes through 90, up to +3, passes and finishes at 180. I can see because it's a 2, I can get a second cycle before my old period of 360. But we're just going to draw one cycle of it, and that definitely matches our graph.
Okay, determine the equation for a sine function that has a period of 120 degrees and an amplitude of 1/2. So you might want to write this on your piece of paper so that you have some notes. I'll give you a second to write it down. Good. So where would I put the 1/2 if that's the amplitude? At the front, like right over here with the 1.
No.
In front of sine. So my amplitude goes right there. On all those other ones, when it had a 4 or a 0.5 or whatever it was, that was my amplitude. So my amplitude goes in front of my sine. Okay, it tells me that I have a period of 120 degrees. So we know the period is 360 divided by K. We need to figure out what the K value is that's going here. Okay, so we know our period is 120. How do I figure out my K? Just switch them, yeah. So I'm going to switch them right there. So my K equals whatever 360 divided by 120 is. So my K is 3. So I'm going to put my 3 theta. So that means in 360 degrees, it's going to go through 3 cycles.